question is find k if 2x square plus 3x plus k equal to 0 has equal roots. Now we compare the given quadratic equation with the general form. So if we compare with the general form, which is ax square plus bx plus c equal to 0, we get the value for a will be 2. So a is equal to 2, b would be equal to 3. So b is equal to 3 and c is equal to k. Now since the roots are equal, we know the condition that if roots are equal, the discriminant value is 0. That is, delta is equal to 0, where delta is the discriminant and delta is nothing but b square minus 4ac is equal to 0. So remember, if the roots are equal, the value for b square minus 4ac is equal to 0. Now we simply substitute these values. So we obtain 3 square minus 4 into 2 into k is equal to 0. So we have 9 minus 8k is equal to 0. So minus 8k is equal to, transferring this 9 onto the right hand side, we obtain minus 9. So therefore k is equal to minus 9 divided by minus 8. So the negative signs cancel off and we get the value of k as 9 by 8. The question is, for what value of k the equation k plus 1 times x square plus 2 into k plus 3 times x plus k plus 8 equal to 0 will have equal roots. Now this is a quadratic equation, right? So the condition for equal roots is the discriminant value must be equal to 0. That is, b square minus 4ac must be 0. So if we compare this equation, the given equation, so comparing the given equation with the general form of quadratic equation, that is ax square plus bx plus c equal to 0, we obtain the value of a as k plus 1. Then the value of b would be 2 times k plus 3 and the value of c is k plus 8. Now we know that for equal roots, the condition is b square minus 4ac is equal to 0. We just substitute these values here. B square, that is 2 times k plus 3 the whole square minus 4 into a, that is k plus 1, into c, that is k plus 8 is equal to 0. Now this becomes 4 times k plus 3 the whole square minus 4 times. Now we multiply these two brackets. So if we multiply the two brackets, we get k square plus 8k plus k, that is 9k, plus 8 ones are, so that is 8 is equal to 0, right? Now we divide throughout by 4 and we get k plus 3 the whole square minus k square plus 9k plus 8. Now here we expand this term a plus b the whole square using that identity. So we get k square plus 6k plus 9. We open this bracket here. So minus k square minus 9k minus 8 is equal to 0. Now k square and minus k square get cancelled off. 6k minus 9k is minus 3k. 9 minus 8 is 1. So that is equal to 0. So we get minus 3k is minus 1. So finally the value of k is 1 upon 3. So this is how you obtain the value for k. Now here we have to solve the equation y plus 11 upon 6 minus y plus 1 by 9 equal to y plus 7 by 4. So let's see how we solve this. So y plus 11, we just put this in bracket, divided by 6 minus of y plus 1 divided by 9 is equal to y plus 7 upon 4. Now we could equalize the denominators over here. We could bring both the terms to their least common multiple, that is 36. 6 times 6 is 36, 9 times 4 is 36. So what we do is, we multiply here by 6, so we get 6 times y plus 11 upon denominator becomes 36 minus 9 4s is 36. So we multiply numerator and denominator by 4. So 4 times y plus 1 divided by 36 is equal to y plus 7 by 4. Now we have equalized the denominator. So we could combine the numerator. 6 times y plus 11 minus 4 times y plus 1 is equal to y plus 7 divided by 4. Now we could multiply 36 on the right hand side and we open up this bracket, both the brackets rather. So we get 6y plus 66 minus 4y minus 4 is equal to y plus 7 upon 4 into 36. Now 6y minus 4y gives 2y, and this difference here is 62 is equal to, now 4 ones are 4, 9s is 36. Again we multiply both these terms by 9. So on the right hand side we have 9y plus 63. So we collect all the y terms on one side. So we have 2y minus 9y equal to 63 minus 62. So we have minus 7y equal to 1. So finally we have the value of y as minus 1 by 7. So this is the required answer.